For the third and final portion of the Chapter 10 lecture, we'll take a look at local and regional circulation systems. So these are winds. As opposed to a big storm, these are winds that can have, in some cases, catastrophic effects. Let's start by looking at the sea breeze. So with a sea breeze, it happens along a coast. It could be a large lake or an ocean. And you have the contrast between land and ocean and the different radiative properties that we talked about. Remember that land heats up quicker than water, so land heats up quicker to higher temperatures. Water heats up more slowly to lower temperatures, but land will lose its heat much more quicker than water. So water stays relatively constant in temperature over a longer period of time. Land varies. It gets hot in the day and then cold in the evening. So in a coastal situation, we end up with the land heating up very quickly. And here you see the isobars. And you can imagine once the land is heated up, the air becomes less dense, the warm air rises, and we get a relatively low pressure, kind of a thermal low, not even really that defined, form over the land, compared to the ocean where the pressure is going to be relatively higher. So what happens here is we end up with the winds wanting to blow from high pressure to low pressure, and so we call a wind by the direction it's coming from. So a sea breeze blows from the sea onto land. So we get this kind of situation during the day. When the winds blow onto land, they follow the circulation pattern. They rise up. Remember, we've got a little bit of a low here, so the air wants to rise up in the atmosphere, and then we get this kind of circulation pattern develop. It's possible that the uplift could produce some weather, maybe some thunderstorms here, but not always. As the day turns into night, the land loses its heat and becomes colder than the nearby ocean. And what happens here is we get relatively higher pressure over land than we do over the ocean. So we get the reverse. We get a land breeze. The air or the winds now want to blow from the high pressure over the land to the lower pressure over the ocean, and we have the land breeze. It's not going to be as strong as a sea breeze, but still we have the reverse situation here. And then mountain and valley breezes occur where we have a valley with mountains that maybe define that valley. And the valley breeze happens because the bare valley walls get really hot. They absorb the solar radiation and they get really hot. On the mountains, remember that air pressure decreases as we rise. So we have relatively lower pressure at the tops of the mountains and then really hot air that is forming inside of the valley here. So that higher pressure, warmer air begins to drift up to the lower pressure areas. So we have a valley breeze. It's blowing from the valley up the side of the mountain. And then to complete the circulation pattern, you can see here the arrows indicating that the colder mountain air sinks down. But along the edge of the mountain or the valley here, we have that breeze blowing up from the valley. We may have some cumulus forms develop here if there's any moisture in the air because of this uplift. And then at night, again, the opposite thing happens. The bare valley walls cool off very quickly, and that cold, dense air that is now near the valley walls sinks down into the valleys. So the air flows kind of down the side of the mountain now and settles into the valley. So we get the reverse kind of circulation happening. Chinook winds are snow eaters. This is called a snow eater wind, and these are relatively warm and dry winds that develop when air is descending down the leeward slope of a mountain range. So the windward side of a mountain range is the side that's getting hit by the prevailing winds. The leeward side is the other side. So in this case, we have a relatively warm air that is descending on the leeward slope, and it warms through the process of adiabatic compression, which we've talked about. If we have a pressure system similar to what we see in this picture here, remember around a high pressure we have clockwise flow, then it's possible that those sinking winds that are coming down the leeward side can get an extra oomph. And in this case, as those warmer winds quickly sink down the side of the mountain, they heat up even more, and they can really move into an area rapidly. And if there's any snow down in the lower elevation, it will be heated to such a warm temperature that the snow gets eaten by the wind, so it can melt the snow. So we have that kind of flow. One of the places that we see this in the U.S. is in Boulder, Colorado, which sits right at the foothills of the Rocky Mountains. They have very strong and destructive downslope winds. These Chinook winds can get up to 100 miles per hour, and they come on very suddenly, and you can imagine that they can cause some damage to the communities. And in fact, they do to this area, to the Boulder area. Santa Ana winds are a type of Chinook wind that blow in the Southern California area where Santa Ana is. And what happens here is we have hot, dry desert winds that form over this Mojave Desert area, which is very hot. And these winds form through from fall into early winter. So in fall, when the desert's just really super heated up from the summertime, we get really hot air, mountains here in Southern California, some mountain ranges, and we get this kind of offshore flow. So the winds are blowing in the directions that you see here, the different paths that the Santa Ana winds can take. And again, that gravity of the downslope flow can push those winds, down into lower parts of towards the surface, and adiabatic compression can heat them even more. So we get very hot, dry winds that blow off the coast of California, and this is typically a time when forest fires can be a real threat. And then finally, catabatic winds are winds that are driven by gravity. So these form uphill. So we maybe have a shallow layer of cold, dense air that naturally wants to flow downhill. And if there's some weather system or pressure system that's going to encourage that wind to go even faster, it's going to really push these catabatic winds down a steep mountain from up high. So places that experience catabatic winds, they're the Mistral and the Bora. The Mistral are in the Alps, very high mountains in Europe, that flow down the Rhone River Valley in France. And then the Bora are in the high plateau region of Croatia that again flow down that topography onto the coastal plain by the Adriatic Sea. So you can read more about those in the textbook. And then bringing it a little closer to home, our local winds here are desert winds. So we have dust devils in the southwest in Arizona. Dust devils form because of temperature. There's an area that gets heated, and very sudden heating maybe in an area, and it causes the pressure to change very rapidly in a very small defined area. And so we get low pressure that forms, and the winds come rushing into that low, and there's a dust devil that forms just from the circulation. Some people think these are tornadoes. They are not. The wind speeds do not get anywhere near that fast, but they can be quite destructive. If you've ever been caught in the middle of one of these, there's a lot of debris that flies around, and that can not be very pleasant. And then our dust storms that we talked about with monsoon season, the haboobs that come, we already talked about those that are part of the monsoon season, kind of in Phoenix and places in the lower desert in Arizona, where you just get this wall of dust, big dust storm that settles into an area. And you see here a couple of links to videos. I will make these available in the additional video supplement. All right, so that's